Hey folks, hope you are doing well. Today I want to talk to you about developing microservice applications on Azure. To introduce myself, my name is Welly Lau. I'm a cloud solution architect in one commercial partner group, Microsoft APAC. Let's take a look at the agenda. I'll start by talking about the background of microservice architecture. We'll then spend some time to learn about the characteristic of microservice applications and then the journey how to get there. I'll then show you a demo of a sample application called eShopOnContainers, which runs on microservice architecture. Now, having learned the benefits and advantage of microservice architecture, it's important for us to also understand the drawback and challenges on this architecture. Then we will see how we can leverage some of the Azure component to ease the challenge, including a great tool called Bridge to Kubernetes. I'll conclude by providing my thought on when to use microservice versus monolithic. And without further ado, let's get started. Okay, I'm a firm believer of this quote from Henrik Ibsen stating that a picture is worth 1,000 words. And I always like to use analogy to explain something, especially something that is rather complicated. And to illustrate microservices, and here's what I think the world before microservice looked like. Huh, I'm using this delicious multi-tier wedding cake as an analogy. And from the picture, you notice that the cake was baked by several bakers, and they are all very carefully decorating, taking care of the cake. And simply because if part of the cake are damaged, it will be very, very difficult to get it fixed. And potentially the customer might even reject it. Now let's try to map this analogy to a real world application. Let's say we are building an e-commerce application like being shown in the picture. So it has the web front end, which consumer browse and shop. The website will then call the web service layer, which possibly ended up calling the business logic layer that doing some validation computation before hitting the data access layer that perform the CRUD, create, retrieve, update, and delete operation to the database. Now, it is a very typical architecture. We typically get it start rather small by only introduce a few simple module as part of our core application. But over time, when we notice that the demand grow, we tend to add more and more capability into it. And as a result, we realize that the code base is very large. And just to share experience, the biggest project that I've worked a couple of years ago, there was about 68 project within one Visual Studio solution. And you can, as you can imagine, that it is extremely long to compile project and the solution. Now, obviously, when there are some issue happens and you get it fixed, the minor change might also result you to recompile the entire application. Now, in addition, one of the drawback about this approach is the fixed technology stack. That means you are unlikely to be able to change to the other technology, given the fact that you have invested into one. And don't you feel that that is the characteristic that somehow resemble the picture that I showed you in the previous video, the previous diagram, which is a wedding cake? Well, yeah, back then we didn't even call it a monolithic architecture. We call that N-tier architecture. The terms of monolithic wasn't even coined yet. In fact, this architecture, yes, was referred then as monolithic, especially when the term microservice began to get popular. All right. Now, well, actually, there's nothing wrong with monolith, as that's how traditionally most of the apps were developed. And in fact, there are many apps today are still being developed with that architecture. Now, this is relevant because it takes longer time to provision and process the infrastructure, and obviously we see a lack of agility back then. Now, the app we developed earlier on with monolith were very hardware dependent. And every upgrade was in fact a risk, especially for some of the mission critical application. Now, over time, with the rise of newer technology, cloud computing, more mature tools, people start to think about, is there a better way, a better approach that we can build applications that can change much quickly and in a much modular fashion, right? And it was then in 2005, Peter Roger used the term micro web service in one of the conference. And a couple of years later, in 2011, in a software architect workshop held near Venice, the term microservice was first coined and agreed to be used as an appropriate name. And then it was later get more popularized by a well-known software architect such as Martin Fowler, James Lewis, and Adrian Cockcross that describe a new paradigm, a new way of building application. Well, then the challenge is, how do you really define microservice? As you can see that we can't find appropriate definitions about microservice in most of the dictionary. So that means it might be means slightly different things to the different people. Okay. Now, at least there are a few characteristics that most people share the common understanding about microservice, and that are pretty much what I'm going to show you in the next couple of slides. First of all, the characteristic is small and independent. The second characteristic is each microservice needs to have the separate code base. The third characteristic is they can be independently deployed. Fourth, it's each of the services are responsible of persisting the data store. And fifth, it's they will be able to communicate each other with a set of well-defined API. And six, they don't have to share the same technology stack, framework, or library. And in addition to these six characteristics, you will notice that often additional components are being brought into the picture when building microservice architecture, which is the management orchestrator and the API gateway. The use of orchestrator is often in conjunction with container for deployment and management. And the API gateway is often used as a facade layer where all of the APIs are connected to. And let's spend a few minutes to review each of the characteristics briefly. First one, microservices are small, independent, and loosely coupled. The tricky part is the word small here. How small? All right, because it is rather arbitrary because there's no specific number defined, right? And some people use the two pizza rule as an indication, right? The team needs to be small enough to be able to fed by two large pizzas, right? So the next point is about the independent and loosely coupled, and this is related to how do you define the boundary amongst or between microservices. The two important rule of thumb that you need to adhere is, first of all, it is perfectly fine to have a high cohesive interaction within the microservice itself, but we need to maintain the loose couple between or amongst a number of different microservices, right? So if the boundary are appropriately defined, it is in fact easier to isolate failure within microservice so that it is less likely to cause a system-wide failure as such. The second characteristic, it's about the separations of code base per each team. So the small team that is responsible of each service has their own respective personnel with specific role like software developer, business analyst, tester, and architect. And they have their autonomy to define how the branching strategy should look like for this microservice, the continuous integration, the continuous delivery strategy. The third characteristic, it's about the independent deployment. Now, before going there, let me show you an illustration of how the typical release of the monolithic application works. In typical monolithic app, because each of the deployments share some dependency, a release is highly dependent amongst all the different teams that are working on different modules. So if team A encounter an issue, even though team B, C, D are good to go, the release won't be able to be successful. And because of that, you won't be able to proceed to production. Now, let's say we fix the issue on team A, and then we realize that actually team C is now the team that is having another issue. Similarly, we won't be able to go to proceed to the release and production. Now, let's take a look at how microservice independent deployment looks like. Because each service is isolated and they do not directly share dependency, they can perform their release independently. So even if there is an issue on team A which stops the release, the other teams still can proceed with the release all the way to the production. Okay, so you notice that the difference between the monolithic way of releasing and deploying as well as this microservice approach. Now, the fourth characteristic, it's about the microservice is responsible for owning and storing their data. This is very different approach with the classic monolith where one database and typically one big database is shared amongst various service and layer. Now, in order to achieve independent scale, each database should store its own database so that in the event of an issue, let's say at the basket database here, user at least still can browse the catalog, although they won't be able to add the basket, but then at least you can isolate the problem at one microservice while the others still function well. Let's move on. The fifth characteristic of microservice architecture. So the two service needs to adhere to a contract before talking to each other, and that should be handled graceful if there is a breaking change, right? And most of the time, they will talk to each other by leveraging REST API. Although we have seen some alternative that is slightly getting more popular, like gRPC. So one important principle here is cross-service database access is not permitted, right? The communication needs to be always go through the API defined by the contract. As such, any proper validations can be performed respectively within the service, and the internal implementation details is hidden from that service. The sixth principle is letting microservice team to decide which technology stack work best for them for the respective own service. So though it is a very flexible approach, you need to be aware that the fact it is rather an expensive practice in terms of manpower skill sets and standardization perspective. So think about, let's say you have chosen a technology stack that makes perfect fit for your microservice, even though you are aware that there are very limited people in the market that have that skill set. What if one of your team member within the team leaves the organization? Then the challenge is it will be very difficult to get another person with a similar skill set. And you can think about if you have chosen 5 different technology stack for 5 different microservice, then that will be quite a big risk. So let's move on to, after spending a few minutes, talk about different characteristics, and let's revisit the analogy that I made earlier on the multi-layer wedding cake. And you can think about microservices as a multi-tier cake, but then they are made from each individual cupcake. And I hope that makes sense for you, similar to the description that I explained earlier on. All right, I'm going to move to the next section to talk about the journey to microservices. And we typically can classify them into 2 different categories. Obviously, each of them will have the pros and cons. The first one is to convert or revamp an existing monolith applications that you may already have into a microservice. Now, you might be able to reuse some of the part of the code, some of the business logic, but obviously, I don't believe you can use all of them. The second way approach is to basically build it from scratch so that you don't have to worry about the legacy. Now, this is arguably can be faster or can be slower. So I'll strongly encourage you to visit this guidance and approach in building microservice here in the Azure Architecture website. So this includes the logical step on how you started with the domain analysis, define the bounded contexts, entity aggregates, and finally to identify each of the microservices itself. So this is quite a rather big exercise, and sometimes you may need to do a couple of rounds in order to size the right microservice. Okay, remember I showed you the e-commerce architecture earlier on in monolith. This is roughly how it might look like if we were to convert it to microservice architecture. So notice that each of the service own their database respectively. They expose themselves through REST API with the API gateway. And in the event where one of the microservice goes down, and let's say the marketing goes down, the other services still can function respectively, though there could be partial degradation, but at least you won't have a system-wide failure. Okay, let me now show you a demo of this project, which is called eShopOnContainer in action. So I'm going to start with showing you where you can find this sample application so that you can learn further after my session, right? So this is available in GitHub. All the source codes are available. You can look at the screenshot of the app. You can also look at the architecture of the app, like shown earlier on. What I'm going to do is show you my Visual Studio instance where the app has been open. So over here, I've got a number of different Visual Studio app project. As you can see that I've got API gateway, I've got service, I've got my web applications, and they have been all deployed to my AKS cluster. So let me show you how my AKS cluster looks like. So you notice that this is called eShop. Okay, so if I were to browse to the URL, what you will be seeing is some UI as following, right? Now it's pretty simple application, nothing fancy. What I'm going to do is first of all log in to this account, and then you will be able to start shop it. Let's say I'm going to shop this thing, the .NET Blue hoodies, and you notice that the cart is available +1, and then I'm going to add one more, and then what I can do is click on the cards and before hitting the checkout. Now, if I were to revisit back the architecture, notice that the UI, there's only one UI, right, which is the website. But then at the back end, they are actually handled by respective different microservice. For example, the identity microservice will be responsible just now when I enter my username and password. And then when I was going to the main page, there will be a list of catalogs. So the one that responsible for populating the catalog was the catalog microservice. And likewise, when I add the basket, it was the basket microservice to handle that. Okay, so what I'm going to do is before I hit the checkout, let's say the catalog microservice really get popular. And because of that, I need to scale my application, particularly on the catalog one, because there could be others that the other microservice might not be as popular. And as such, what I can do is go to my AKS and pick up the YAML deployment of this particular deployment. And what I can do is modify this into 5 instances. If I were to change the value into 5 and I click review plus save, you will notice it will tell you that actually you have changed the value from 1 to 5. You really want to do that? And I say, yes, I'm going to confirm the manifest change, and I click save. And what it does, it will help you to update the Kubernetes deployment object, and at the same time help you deploy a number of multiple instances. And as you can see that just now, I started with 1, and then over the time I changed to 5, and now what it does is Kubernetes will start to increase the number of instances to 5 for me. Again, remember, it's just for particular the catalog service, so I can scale independently with without affecting the others. Okay, now what about sudden thing happens in my ordering microservice, right? Remember, the moment I'm going to hit checkout, what it does is actually hitting the order microservice, as you can notice from this diagram. Now, in the event of my ordering microservices down, now obviously that's not a very good thing, but at least if I were to, again, change this YAML file, and now instead of 1, I'm going to change to 0. That means that there's no pod that is handling that microservice, and I confirm doing that, okay? So there's no more microservice being provisioned for this, and that's a terrible thing. But at least you notice that my application, it's still up and running. So yes, it's not perfect, right? Because even though I still can log in, you see that I'm still logging in, and I can add to cart. However, I won't be able to order it because what? The application is down. Okay, so if I were to hit the cart, I won't be able to. Oh, I'm getting a bit of error message here, but at least my entire application is not down. I still can browse my product. I still can be able to look at what is available on the product. And that's the beauty of microservice architecture. All right, I'm going to move back to my slide. You have seen the benefits of microservice architecture as we highlighted in the characteristic, but I think it's also fair to highlight you some of the drawback and challenges as well. Basically, it will contribute to a much complex system, at least compared to a monolith. So let's take a look at each one. Um, First one, it's about development and testing microservice. So the question is, should you host all of your service within the local development, just like what I did in the demo that I show you? Everything is in my Visual Studio, or should you connect remotely? And each of them will have their obvious pros and cons. Now, furthermore, testing them add actually more complexity. The fact that they are all out of process, they are not within the single process. They are all running in different process. A second point is because of the nature of out of process, you need to supply additional effort in handling the failure in case one happen. Patterns such as asynchronous communications, retry policy, circuit breaker can be really helpful, but then applying them actually require additional effort. The third challenge is because each of the service store their own data, you can't easily just use a transaction object like how you traditionally did in SQL Server to perform a transaction, right? So you might need to adapt things like eventual consistency or Saga pattern to compensate that distributed database challenge. Fourth, it's about implementing change. Well, to be precise, this challenge is not exclusively to microservice because it might happen in monolith as well. But you need to be very cognizant in adhering the contract, especially if there is a breaking change. Fifth, it's about the deployment itself. We learn about the beneficial characteristic, being able to deploy the service independently, but this needs to be carefully planned, especially when you have quite a large number of microservices. Now, therefore, I think leveraging the tools like automations and DevOps toolings are definitely a good idea. All right, now let's learn about what are the critical success factors of a microservice project. Azure and Microsoft can help on some of the aspects, and obviously not all of them. The first critical success factor is about people, culture, and the methodology. So this is a big topic which requires significant culture shift and learning curve. This is in fact not so much of a technical aspect, but more people and process. The second factor is about technical skill set. The modern software development practice skills are essential in producing a good microservice project, right? So things like API-driven architecture, decoupling, applying unit testing, event sourcing, the Saga pattern, CQR actually stand for Command Query Responsibility Segregation. They are all very good practice that you can use in microservice architecture, though it's not exclusive, right? You can pretty much apply the same pattern in the monolith, but that's definitely makes a lot of sense when you use in conjunction with a microservice apps. The third, it's about the tools and the platform provided services such as Visual Studio, Visual Studio Code, a bridge to Kubernetes, and some of the relevant Azure services. And that's what I'm going to talk about it in a couple of slides. I'm going to show you a few components starting from DevOps, hosting platform, DevTools, database, and so many more. As you can see that we not only have the Azure provided first-party solution, but Azure also allow you to choose which third-party or partner solution which makes most sense for you to adopt within your solution. I'm going to spend the next couple of minutes to discuss a bit more on the development tools, especially on the Visual Studio Code with the bridge to Kubernetes, which offer some benefits is your microservice development experience. Okay, there are three different approach in developing microservice architecture. Typically, in the context of you are working on the service which part of the larger solution. Okay, the first approach is developing your service locally with the other dependency also built in your local machine. Now, those dependency could be in form of mock, stub, or even a Docker compose file, right? So, but the key point is they reside within our dev machine. So this approach has many benefits, especially they are very convenient to developer. They are much faster to build, to debug. But the downside is your dev machine could be potentially overloaded. However, one of the challenge is there might be quite a big difference between your local dev machine versus the actual deploy environment in Kubernetes cluster. The second option, which is what we call as remote, is basically enable you to focus your app that you deploy locally, but when it comes to debugging and testing it, you take the change that you made and you deploy it to the remote Kubernetes environment. And the benefits that you're getting is it's very consistent experience to your ultimate deployment. But the downside is that require extra step, extra friction, which reduce somehow the productivity of the developer. The third option is actually where a bridge to Kubernetes falls in, and we believe that you can take advantage of both approach, and this allow you to develop locally and make use of tools like bridge to Kubernetes to connect the dependency which resides in the real actual Kubernetes cluster. And with that, I'm going to with the bridge of Kubernetes. It used to be referred as local process with Kubernetes, provide an integrated experience with Visual Studio or Visual Studio Code, and it support any difference of Kubernetes cluster. It will eventually supersede Azure DevSpace, which will be retired in 2023. Some of you might be familiar with the Azure DevSpace, so we make an announcement that it will be eventually retired, and then Kubernetes, bridge to Kubernetes is the one that we are moving forward with. So let's take a look at another sample application, and this time around it's a bike sharing application. As you can see that I've got my workstation here, like Welly web station, and Welly is working on the bike microservice, and I'm using Node.js and Visual Studio Code locally. And how it works is how it works is bridge to Kubernetes will place a redirector within the Kubernetes cluster. So when I send my request from my local to the Kubernetes cluster, everything actually still will be served normally until that particular service that I have configured was reached, right? Because what happened is when the byte microservice on the Kubernetes cluster that I have pre-configured, when it is reached, what it does is reroute to my local version. Right? So the same thing applies to my colleague, let's say Adam. And Adam is working on the reservation engine, but he's using .NET Core and let's say with Visual Studio, right? Similar thing happens in their concept, and we can work independently without stepping on each other code, and that's a lot more efficient. Okay, I'm going to show you now the demo of these bike sharing apps. Um, to do that, let me move to, first of all, the Visual Studio, right? So here's the Visual Studio, right? So you notice that within the Visual Studio, I only have this this solution called app, but then actually it is just a reservation engine. So it doesn't contain all other microservice as I showed you earlier on. So it doesn't have the buy, it doesn't have the review and have so many more. This is purely the code of the reservation engine. Okay. Now, likewise, if I can show you another solution that I have here. So this is so-called a bikes microservice. So this bike microservice only contains the information of the bike, right? So let me revisit my previous slide to make sure that you remember that we have user microservice, we have reservation, and we have bike reservation engine, and eventually the billing one. Okay, so each of them are independently. So coming back to the VS Code here. Okay, so this is the bytes only microservice. So what I'm going to do next is to show this application that has been successfully deployed in the AKS cluster. So you see that this is deployed in a cluster called Valley AKS2. And if I were to browse the URL, so this is what I'm getting, right? So a very simple app, nothing fancy. What it does allow me to do is sign in with one of the test user. And once I'm getting in, I'm allowed to pick one of the bike where I want to rent. Okay, and I'm going to choose the bike, and I click the rent bike. Okay, notice one thing that I noticed that the picture of the bike does not show correctly. Okay, so I bet there should be some bug that we need to get it fixed. Okay, so let me show you then. So here's a code. Okay, so and assuming that I know that, oh, in order to fix the error, actually what I need to do is just comment this one because the fact that this is hard coding. So I'm going to save this. Okay, so what I'm going to do first of all is make sure that the bridge to Kubernetes extension is installed. Okay, so I come to the marketplace extension and I type bridge, and you notice that this thing called bridge to Kubernetes. So this is installed. I need to make sure that it is first of all installed. Okay, now once we are done with this, the next thing that we need to make sure that the Visual Studio Code here, the solutions, is connected to the right cluster, right? In my context, it was the by app within the AKS2, right? So in the previous session, I showed you about the Kubernetes extension for Visual Studio. You notice that now I have to make sure that this by app is used, this namespace is used, and I can also show you that it is connected correctly to the cluster called AKS, Valley AKS2. Okay? Now, what I'm going to do next is to perform a configuration such as my VS Code to be able to reach to the cluster with bridge to Kubernetes. And to do that, I'm going to hit Control-Shift-P to show this command palette, and then choose this one called bridge to Kubernetes configure. So I have to make sure that this is properly configured first before everything goes well. Okay, so I can also click View and Command Palette and hit Bridge to Kubernetes. Now, first of all, what it does is actually, because we have successfully associated my local Visual Studio to the AKS, it will show me a list of service. So these are Kubernetes service, and it will ask me which one do you want to connect to. Now, because I am working on that particular byte service, I just choose byte. And the next step is actually asking me about the local port. So I'm going to go ahead with the 3000, okay? And the next action will tell me how do you want to launch it? And I say, because it's a Node.js app, I'm going to launch it with npm. And this option is actually asking me whether or not do you want to only route the traffic that is related to my service, which I'm working on, or you want to make sure that all other developer can also reach from my service. Okay, so with that option, I'm going to choose yes, so that it only applies to me. So what it does is will actually put the configuration in a set of config file. Okay. Um, so the next thing that I'm going to do is to go to the debug section here and hit run. Okay. So what it does, it will, when I click run, what it does, it will begin the communication from my local VS Code to the yeah, this is the step that you have to do. It does require an admin access, so that make sure that the Kubernetes cluster to be able to reach your local. All right, so you have to do that, give that permission. Okay, so what it does is perform a redirection, um, and we use this tool called Endpoint Manager to perform the authorizations. As you can notice that routing has been successfully enabled. All right. So what I'm going to do next is connect to a browser, but then in this time, I will use a slightly different endpoint to connect to. So let me show you. So this was the original. So this was the original endpoint. Okay, by app dot by sharing dot blah blah blah. Okay, so what I'm going to do now is on my particular namespace, let me refresh to see whether if it is still relevant. Okay, now it's no longer relevant, so I'm going to find the right service. Um, so that's the one. Okay, and I am going to come back here and replace this with this new one. I'm going to hit run. Okay, there we go. Now I am connecting in my in a cluster. It's a sub elements in the cluster, and I can do the same with one of the user. And now before doing that, I can show you that I actually have made a breakpoint in my VS Code, right? And within that VS Code, I hit a breakpoint here, okay? And I'll be able to jump over, and you notice that the code is actually calling back to my local machine, even though this is running in the cloud, okay? So I'm going to do it one more time to make sure that everything goes well, okay? So you can see that every single step that I did here, even though my code is running on the cloud with this URL, but then it actually hit back to my local Visual Studio instance, okay? So, and let me untick this endpoint and make sure that um, this is successfully accessed, okay? I can hit return by, and there you go, confirm returns. Yes, I'm having a good time, and click submit, okay? So look at that. This is still happening on the cloud, though it allowed me to get back on-prem with the code that I changed earlier on with fixing this bug of hard coding this. Now I can get this installed locally. Okay, let me hit one more time, put this as a debug point, and the moment I hit F5 or refresh this page, you see that the traffic is actually stopped by to my local traffic, and I can proceed again. Okay, so I hope that makes sense for you. All right, I'm wrapping up this session with some of the conclusion and thought. Okay, one of the very common misconception and confusion is the term microservice with container. Right, we learned about container in the previous session. Right, container being a lightweight and a deployment and packaging mechanism that will be able to containerize and zip your application model. Right. It is actually not container, right? Although container and microservice plays together really well, but they are two different things. Okay. Um, Now, container is not the only way to implement microservice architecture. You can also use the other technologies such as serverless to implement microservice architecture, and that's perfectly fine. Um, all right, as a conclusion, I believe we all agree the fact that there's a lot of benefits of using microservice architecture, but it's important to also weigh the drawback, right? So that we can use the right approach at the right time. Now, for me, I think microservice applications make a lot of sense when you are developing the solution with high frequency change and um, a lot of number of different delivery as well. But monolith application makes more sense for those who are one-off projects. So you basically capture a customer requirement for one time, you code then some price, and then you're going to deliver it. So that makes more sense with monolith. So if you organizations also allow you to have a liberty option to choose which technology stack that you want to, I think that's also a good reason to use a microservice architecture, or else perhaps monolith is a better approach. Timeline is a tricky one because many of the developer who are transitioning from monolith to microservice face quite a fair bit of learning curve. As such, make sure that you factor in additional buffer time as part of the effort until the team feel a lot more comfortable. Now, what about the other factors like scalability, availability, and reliability? And I feel this is a very subjective topic as we can apply those practice regardless whether it is a microservice or monolith app. So I really leave it to you in order to make the appropriate decision for you. Okay, feel free to check out this GitHub page. This comes together with a free ebook that explain the concept of microservice, including some of the principle in much more detail. I think that's a great book that's available on the link. Um, and the followings are also a list of reference that I used to compile these presentations. A lot of good links here. Feel free to check them out. And with that, thank you so much for watching this video. See you next time.